So here we have an application of the sine angle sum formula. So let's start with that formula. The sine, we'll use the symbols they have here. X plus phi is equal to, it starts off with the sine of x, then it switches to the cosine. And then if there's a plus with the sine, there's a plus in the other side of the formula, and then it switches again, cosine, sine. So that's the formula there. Now, this is augmented with that a in front, so we're going to have a multiple of a here. And so the claim is we can take this object here and rewrite it as that one. So we just want to compare the two of those. So I'm going to write underneath this left side. So the left side has a -3 sine of x plus 3 cosine of x. And so we can see here that there's a sine of x there and a sine of x here. Those line up. Cosine lines up with cosine there. And then we've got the a cosine of phi. Phi is some constant. It's going to be some number between -pi and pi. That matches up with our -3. And then our a sine of phi, again, phi is a constant, so sine of phi is a constant. That has to match up with that 3 right there. So what we get next is that a cosine of phi from the first part, has to be -3, and a sine of phi has to be +3. And then we use the Pythagorean identity, sine squared plus cosine squared, and the short work of that ends up being, after a few steps that we've done a couple times in the past, and the book illustrates this too, that you get this first value squared plus the second value there squared has to equal a squared. So applying the Pythagorean identity here leads to this conclusion. So I'm just going to jump to the conclusion because we've done that a few times before. Pythagorean identity. All right, so we applied that in the past. That led us to this conclusion. We're just going to jump to that conclusion. So we're going to get 9 plus 9 equals a squared. Rewriting that, I'm going to write a squared first is equal to 18. So a has to be plus or minus the square root. We're just going to go with the square root. And 18 is 2 times 9, so that reduces to square root of 9 is 3, square root of 2. So we get a value for a there. Next, we have to find a value for phi. So I usually grab the cosine to do that. So now combining this with this, I get 3 square root of 2 cosine of phi equals -3. Divide by 3 square root of 2. Cosine phi is -3 over 3 square root of 2. That reduces to -1 over the square root of 2, or negative square root of 2 over 2. And I recognize, hey, I know that value right there. So thinking about the unit circle. In the unit circle, remember cosine's an x value. So negative square root of 2 over 2 is around -0.7-ish. So about -0.7-ish. So that would be x here. So if we applied the arc cosine, it's going to look up here for that angle, for that x value. And so it's going to give me that angle right there. And square root of 2 over 2 is related to pi over 4. So we're going to have 1 pi over 4 here, 2 pi over 4. That should be 3 pi over 4. So I believe that phi is 3 pi over 4. And that angle is less than pi and positive. So it's in this right side of the interval they asked me about there. So my belief is that original 3 negative 3 sine of x plus 3 cosine of x is equal to a, which we found to be 3 square root of 2, and phi we believe is 3 pi over 4. So we think that function is equal to, and we're going to graph this to check, 3 square root of 2 times the sine of x plus 3 pi over 4. All right, so let's graph to see if that's right. So remember, you always want to verify before you hit that check my answer button. All right, Desmos here. So the original one was negative 3 sine of x. Oops, not 6. Oh, that reminds me of a funny trig joke. It's actually not that funny, but I think it is. Plus 3 cosine of x. All right, so that's the original wave they gave me. And we think that can be rewritten as 3 square root of 2 times the sine of x plus 3 pi over 4. Nailed it. Notice that the blue wave, if I turn it off, sits right on top of the red wave. All right, so we did find a multiple and a phase shift. So new amplitude phase shift is this sine plus the cosine. And it turns out because of the double angle formula, we can always do that. Sorry, not the double angle, the angle sum formula. So again, we found A to be 3 square root of 2 and phi to be 3 pi over 4. And the graph confirms that. Oh, my stupid trig joke. I gotta show you that quick. So this is a bad math joke, literally in 2 different ways. So simplify the sine of x over n. And my claim is that that is equal to 6. And if I cancel the n's, then I get 6. There's my bad math joke of the day. It's a bad joke, and that was bad math.